Dear students, welcome to the problem solving session on change of order of integration, part 6. In the first two videos, we see problems on a single triangle. In the third and fourth video, we see a triangle with two different regions when we do the change of order. Very interesting problems. And the previous video, that is part 5, we solve change of order of integration where we get two different regions when we do with a straight line and a parabola. Now, in today's session, we are going to see another excitement video. Change the order of the given problem. See here, both my inner integral limits are not linear. So that means here y is the variable, y equal to x square by 4a. On the other side, y is equal to 2 into root ax. So when we simplify this, we'll be getting x square equal to 4ay. On the other side, when you square, you'll be getting y square equal to 4ax. Oh my god, do you remember this? In our school days, this is the parabola open at the top and the second one is the parabola open at the right. So that means now we are going to find the intersection between the parabola open at the right and the parabola open at the top. So my region is going to be this one. So I have given the problem in a very simple way. Let's do it. Step 1. So here we have dy and here we have x. Opposite poles attract. So it is correct format. So let us take the capital I. Step 1 gets over. Step 2, as usual, I have to write the equation. So x has constant limits, that is 0 to 4a, x equal to 0, x equal to 4a. Now we are going to write the inner limits, y equal to x square by 4a. When you simplify this, we will be getting 4ay is equal to x square. That I can rewrite it as x square equal to 4ay. Next, y equal to 2 into root ax. Simplifying this by taking square on both sides, y square is equal to 4ax. So both are parabolas. That is the knowledge we have. This is the parabola open at the top and this is the parabola open at the right. But we don't know what is the exact intersection point, all this thing. For this, we need furthermore investigation. So as usual, you see here, these two equations are known to be x equal to 0, x equal to 4a. They are going to be parallel to y-axis somewhere. This is x equal to 0 and this is x equal to 4a. Now we have to find this two parabola and what are all the points it will pass us through. So as usual, take down these two equations. Now we know x equal to 0 and x equal to 4a. Substitute x equal to 0 here, we will be getting y equal to 0. Then substituting x equal to 4a, we will be getting 4a whole square is equal to 4ay. Now cancel 4a, we will be getting y equal to 4a. Similarly, substituting the value of x equal to 0, you will get y equal to 0. Substituting x equal to 4a, then y square is 4a whole square. Y is equal to 4a. Because all the values are positive, I am taking only the positive values. Now we can see the 4 points 0, 0, 4a, 4a. Here also 0, 0, 4a, 4a. Very good. Both the parabola are going to intersect only at the origin 0, 0 and the second point is 4a, 4a. Done guys. We have almost got the idea. Let us go into the given order is dy dx and change of order is dx dy. That means given order we have vertical strip bottom to top. Change of order is going to be horizontal strip left to right. Next, step 4. In step 4, I am going to draw the diagram directly because past 4 or 5 videos, we are thorough with drawing the figures. We know all the equations, lines, etc. So we have two lines here, that is 0 to 4a. I am going to draw directly. So x equal to 0, x equal to 4a. Done. Next, x square equal to 4ay and y square equal to 4ax. This is my two parabolas. It passes through the same point 0, 0, 4a, 4a. So I am going to draw this parabola first. Why? You see the question. Integral over 0 to 4a, x square by 4a to root ax. That means this x square by 4a is my lower parabola and y square equal to 4ax is the parabola which is in the upper limit. So I am drawing this parabola x square equal to 4ay. The next parabola will pass us through the same line 0, 0 and 4a, 4a. Now we should be very careful in choosing the region. In all the previous problem, we choose the closed region. Here I have two regions, but you should be very careful in this. So the line starts from x equal to 0 and it moves up to x equal to 4a. When you come for the variable, the parabola is starting from here. This is the starting parabola and it ends up here. So the area common between these two parabolas is the region which I have to found. Hope you understand, students. So I am just zooming this. This is what the region I want to find. Given order is dy dx. So I have a vertical strip. I can draw the vertical strip here. Wherever I draw the vertical strip, it goes from the lower parabola to the upper parabola. Now, given order is dy dx. Change of order is going to be dx dy. So I'm going to draw from this parabola, that is y square equal to 4ax to x square equal to 4ay. I'm going to draw this strip. Next, we are going to write the limits. This is my diagram. Since horizontal strip is there, x limits are variable, y are constant. So horizontal strip travel always from left to right. Now therefore, my left limit you see y square equal to 4ax. So x equal to y square by 4a. I can write like this. 2, it goes to the other parabola. X square equal to 4ay. If I take root, it will become x equal to square root of 4ay. I can write this as 2 into square root of ay. This is my x limit. When I go for y, it is going to be a constant. So the minimum value of y from the point is 0. Maximum value of y from the point is 4a. So 0 to 4a. Done, students. Now I want to write the integral. So capital I is equal to double integral change of orders dx dy. I don't know the function. Let us consider. So I'm writing f of x comma y. Y limits is 0 to 4a and x limit is y square by 4a to 2 into square root of ay. That's it, students. This is the change of order of integration for the given problem. Next, we have to do the integration for. When I integrate x with respect to dx, y is constant. So x square by 2. When I put the upper limit, I'll be getting y into 2 into root ay whole square is going to be 4ay by 2 minus, if we substitute this lower limit, it is going to be 1 by 2. Already we have y square by 4a. If we substitute in x square, it becomes y power 4 divided by 4 square is 16 into a square. I am giving you a very slow, I am giving you the complete explanation. Done. Now we are going to integrate this with respect to y. For this, I have to multiply this y inside, otherwise I'll be in trouble. So 4ay square, then y power 5. See here 1, 2 and here 1, 2 is common. I will take this out. So 1 by 2, 0 to 4a, 4ay square minus y power 5 by 16a square dy. Integrating this, we will be getting 4ay cube by 3 minus y power 6 by 6, 16a square. Now lower limit is 0, upper limit is 4a. Now simplifying this, we will be getting 1 by 2, 4 power 4, a power 4 divided by 3 minus 4 power 6, a power 6 divided by 6 into 16 into a square. Now I can take a power 4 outside in common. So it is going to be a power 4 by 2, 4 power 4 by 3 minus 4 power 6 into a square by 6 into 16 a square. A square get cancelled. 16 get cancelled. 4 power 4. So 4 square is 16. 16 into 16 a power 4 by 2. This is going to be 1 by 3 minus 1 by 6. So when I simplifying this further, 16 into 16 divided by 2 a power 4. When I take LCM, I'll be having 18. 6 minus 3. So now this will get cancel and then here I can cancel. So now 16 into 4, 64. Here 6 minus 3 will become 3. So that 3 will get cancelled with this 9 and we'll be having 64 by 3 a power 4. This is my solution, guys. Therefore, the answer is 64 a power 4 by 3. Now take the same problem. Instead of xy, I just left it as simply dy dx. Try to solve this problem for your practice.
Thank you for watching. We hope you found this video helpful. Stay tuned for more and keep up the great work. Subscribe to our channel and see you in the next video. Bye bye.